Imagine a computer that doesn't just process information, but experiences every possible answer simultaneously. That's not science fiction, it's the reality of quantum computing, and according to leading experts like IBM's Dario Gil, this paradigm shift is already underway. A regular computer solves problems one step at a time, moving sequentially. A quantum computer, however, can explore all potential solutions simultaneously, a fundamental difference that computational theorists at Google and Microsoft confirm is about to redefine processing power. This single, critical distinction is poised to break every password, every encryption, and every security system on Earth, creating a digital vulnerability unlike any we've ever faced. To grasp this power, we must first understand its core. Traditional computers use bits, electrical signals representing either a 0 or a 1. It's definitive, like a coin lying flat, either heads or tails. But quantum computers utilize qubits. As Dr. Michio Kaku explains, a qubit can be both 0 and 1 at the same time, thanks to quantum mechanics. Picture a coin spinning in the air, it's neither heads nor tails until it lands. This superposition allows qubits to hold exponentially more information than classical bits, providing the foundational boost for unprecedented computational abilities, a concept pioneered by physicists like Richard Feynman decades ago. Beyond superposition, quantum computers leverage entanglement. This is where two qubits become inextricably linked, regardless of distance. Change the state of one, and the other instantaneously reacts, a phenomenon Albert Einstein famously called a spooky action at a distance. Researchers at institutions like TU in the Netherlands are actively exploring this phenomenon. This interdependency allows quantum computers to process complex interactions between pieces of information in ways classical systems cannot, creating a parallel processing capability far beyond anything we've conceived. It's like having every piece of a jigsaw puzzle instantly know where all other pieces are, simultaneously. Coming in at number 5, the quantum computer's power to simulate molecular interactions could unlock revolutionary advancements in materials science and drug discovery. Scientists at pharmaceutical giants like Pfizer and material innovation hubs are already investing in quantum research. This isn't just about faster simulations, it's about modeling complex systems with an accuracy currently impossible for classical supercomputers. Imagine designing new superconductors at room temperature, or creating drugs perfectly tailored to individual genetic profiles. The benefits are immense, promising breakthroughs in medicine, energy, and technology that could fundamentally reshape our world for the better. This is the positive, albeit still terrifying in its scope, side of quantum power. Our fourth major threat, or opportunity, is quantum computing's potential to turbocharge artificial intelligence and machine learning. Current AI models require vast datasets and immense computational power to learn. Quantum machine learning algorithms, as explored by researchers at Google AI Quantum, could process these datasets in fundamentally new ways. This could lead to AI that understands complex patterns in data with unprecedented speed and accuracy, accelerating everything from autonomous systems to advanced predictive analytics. While promising medical diagnoses and climate modeling, this also raises profound ethical questions about autonomous decision-making and control, a concern voiced by groups like the Future of Life Institute. Third on our list is the profound threat to global supply chains and financial security. Many modern supply chain logistics, inventory management, and financial transaction systems rely on complex optimization problems. Classical computers struggle with these NP-hard problems as the number of variables grows. Quantum algorithms, specifically optimized for such tasks, could solve them exponentially faster. According to a report by the World Economic Forum, this means vulnerabilities in logistics could be exploited for massive disruption, and financial markets could face unprecedented risks, from sophisticated arbitrage to systemic fraud, if current security is breached. The scale of potential disruption is truly staggering. The immense potential of quantum computing has ignited a fierce global race. Nations like the United States, China, and the European Union are pouring billions into research and development. The National Quantum Initiative Act in the US alone committed over $1.2 billion, while China's national laboratory in Hefei is a quantum powerhouse. This isn't just about scientific prestige, it's about future economic and military dominance. Experts like Dr. Sarah Blundell from the University of Oxford emphasize that the first nation to achieve truly fault-tolerant quantum computers could gain an unparalleled strategic advantage, shifting geopolitical power balances in ways we can barely comprehend today. Our second most terrifying threat targets the bedrock of all modern Internet security, public key cryptography. This system, like RSA encryption, relies on the mathematical difficulty of factoring very large numbers, a task that would take classical supercomputers billions of years. But Schia's algorithm, developed by Peter Schia in 1994, provides a theoretical quantum solution that could perform this task in mere minutes or hours. The National Institute of Standards and Technology, NIST, confirms that a sufficiently powerful quantum computer would instantly break virtually all current public key encryption, compromising secure websites, banking, and government communications. This isn't speculation, it's a mathematical certainty once the hardware catches up. In anticipation of this quantum apocalypse for current encryption, a frantic race is underway to develop post-quantum cryptography. These are new cryptographic algorithms designed to be resistant even to quantum attacks. NIST is currently leading a global effort to standardize these new algorithms, with several candidates under rigorous review. The transition, however, is monumental. As cybersecurity expert Bruce Schneier warns, replacing all global encryption infrastructure will be a decade-long, multi-trillion-dollar undertaking, fraught with implementation challenges and potential vulnerabilities. The clock is ticking, and the question isn't if, but when, quantum computers will render our current security obsolete. The concept of quantum supremacy or quantum advantage marks the point where a quantum computer can perform a task that no classical computer, no matter how powerful, could complete in a reasonable timeframe. Google claimed to achieve this in 2019 with its Sycamore processor, solving a specific problem in minutes that would have taken the world's fastest supercomputer thousands of years. While the exact implications are debated by critics like IBM, who argued the classical comparison was unfair, the milestone undeniably demonstrated the fundamental power differential. It proved that the theoretical advantage of qubits and entanglement is now being translated into tangible, though specialized, computational superiority. Despite the hype, some still recall the AI winter and predict a similar quantum winter, a period of reduced interest and funding due to unfulfilled promises. However, leading venture capitalists and government reports suggest a different trajectory. Unlike previous technological booms, quantum computing is backed by solid theoretical physics and significant, consistent investment from both public and private sectors. Companies like IBM, Google, and Amazon are not just dabbling, they are building commercial quantum services. As experts at McKinsey and Company point out, the progress, while challenging, is real and accelerating, indicating a sustained push rather than an impending slowdown in the quantum space. At the absolute top of our list, the most terrifying implication of quantum computers hits closest to home: the obliteration of personal privacy and the rise of unprecedented surveillance capabilities. Every encrypted message you've ever sent, every secure transaction, every private file protected by current encryption could theoretically be retroactively deciphered by a future quantum computer. Government intelligence agencies are already collecting vast amounts of encrypted data, waiting for the day quantum decryption becomes viable. As privacy advocates from the EFF warn, this means a future where your past digital life could be entirely exposed, creating a world with no digital secrets, transforming the very definition of personal privacy as we know it. While quantum computers pose threats, the emerging quantum internet offers a potential silver lining, but one with its own terrifying implications. This future network would leverage quantum entanglement to create fundamentally unhackable communication channels. Quantum cryptography, specifically quantum key distribution, QKD, could ensure perfect secrecy, theoretically. However, building and maintaining such an infrastructure is immensely complex and expensive. Furthermore, if only a few powerful entities control the quantum internet, it could lead to an unprecedented centralization of secure communication, creating a new digital divide and potentially allowing surveillance from the very top. The future of secure communication is a battleground. So, what can individuals and organizations do to prepare for the quantum era? The first step, according to cybersecurity firms like CrowdStrike, is awareness. Identify critical data, understand its lifespan, and begin evaluating post-quantum cryptographic solutions. Governments and large corporations are already migrating to new standards, but small businesses and individuals often lag. Backing up data, using strong, unique passwords, though even these will eventually fall, and staying informed about advancements in post-quantum cryptography are crucial. The transition won't be instantaneous, but proactive measures today can mitigate the catastrophic impacts of tomorrow. It's not about fear, but about preparedness. The immense power of quantum computers presents a profound ethical dilemma. On one hand, the potential to solve humanity's greatest challenges, from climate change to incurable diseases, is within reach. On the other, the capacity for unprecedented surveillance, algorithmic bias, and destructive capabilities is equally plausible. As ethicists at the Oxford Future of Humanity Institute argue, the development and deployment of quantum technology demand careful consideration and international cooperation. Without clear ethical guidelines and governance frameworks, humanity risks creating a tool that, while incredibly powerful, could unravel the very fabric of our society in unforeseen and terrifying ways. The choices we make now will define our quantum future. From understanding qubits and entanglement to ranking the 5 most terrifying implications, it's clear quantum computers are not just another technological advancement, they represent a fundamental shift in our capabilities and vulnerabilities. We've explored how they could break encryption, revolutionize AI, and redefine personal privacy. The quantum era is not a distant dream, it's a rapidly approaching reality that demands our immediate attention and understanding. The power is undeniable, the potential both miraculous and terrifying. How we navigate this new dawn will determine whether quantum computing becomes humanity's greatest achievement or its most profound regret. The future is quantum, and it's time to prepare.